welcome to a review on factoring. Factoring. Okay, this is so important in grade 11. You must know how to factor. There's so many questions that involve factoring, and if factoring is a struggle for you every single time, then grade 11 math is going to be a struggle for you, I promise. But if you can get the factoring down, then I just can't even tell you how many times you're going to have to factor in this course. So let's do a little review about factoring. Basically, there's 4 types of factoring that you should know. The first type is removing a GCF, a greatest common factor, right? Removing a greatest common factor. So an example of that would be a question like 12x squared y cubed z minus 20x cubed y cubed z squared plus 16x cubed y. Okay, we want to take the greatest common factor out of this question. There's 3 terms here. Every time you see a minus sign or a plus sign, it separates terms. So there's 1 term, 2 term, 3 terms here. So what you're going to do is you're going to look at each part individually. First of all, you're going to look at the numbers. 12, 20, 16. What's the biggest thing you can divide them both by? You can divide them both by 2, but a bigger number you can divide them both by is 4. Okay, now we look at the x's. X squared, x cubed, x cubed. What's the most x's you could take from each one of them? You can't take 3 from each of them because you can't get 3 out of this one. So the most you can get from each of them is x squared. The way a lot of people think of it is take the smallest exponent. 2, 3, 3 on the x's, smallest number is 2. For the y's, we have 3, 3. What's on this one? 1. So smallest is 1, so we can only get a y out of there. Z, we've got 1z, 2z, and no z, so we can't take any z's out. You can't get a z out of this one. This is your greatest common factor, 4x squared y. Okay, now what we do is we open up the bracket and we ask ourselves, what do we need to multiply 4x squared y by to get each of these terms? So what do you multiply 4 by to get 12? 3. What do you multiply x squared by to get x squared? Well, by 1, so you don't need to write it down. You already have enough x squared. What do you multiply y by to get y cubed? Y squared. Another way to think of it is, if we have 1y here, how many more do we need to get the 3? We need 2 more. And we also need 1z. Okay, there's the first one. Minus 4 times 5 equals 20. X squared, we need 1 more x. Y, we need 2 more y's. Z, we need 2 more z's. We don't have any z's in the greatest common factor. And the last term, 4 times 4 is 16. X squared, we need 1 more x. Y, we don't need any more y's. We already have 1 y, and that's what we want in the final term. So we're finished. This is the answer right here. Remember, what we're doing here is we're going backwards from the mountains, right? If you wanted to, you weren't sure of your answer, you could multiply this by this by this, and this by this, and you know what you would get? You'd get what we started with back up here. Okay? That's removing a greatest common factor. Second type of factoring I want to talk about is when you start with a binomial. So this would be something like 25x squared minus 81. Okay, another name for these binomials, it's a difference of squares. Okay, why is it called a difference? Difference because there has to be a minus sign in between here. If there's a plus sign, you can't factor it. It has to be a minus sign. Why is it binomial? Because there's 2 terms. And why is it squares? Because each one of these 2 terms is a perfect square. There's something you can multiply by itself to get 81. There's something you can multiply by itself to get 25x squared. So if you had something like 4x squared minus 15, this is not a binomial that you can do difference of squares in because this is not a perfect square. If you had 4x squared plus 16, this is not a binomial that you can do difference of squares because you have a plus here. But if you had 4x squared minus let's make it 25, you could do this one, because this is a perfect square, and this is a perfect square, and there's a minus in between, okay? That's what is necessary in order to factor a binomial. Oh, one thing I forgot to say, back up here with removing a greatest common factor, I know you now remembers this from last year, because he said it over and over and over for me. You must try, you might not be able to, but you must try to do this first when you factor. So for example, in this question here, the binomial, is there a greatest common factor that we can take out of there? Is there something we can divide 25 and 81 by? No, there's not. So there's not a greatest common factor, but there is going to be greatest common factors often. Okay, all you do for these ones, you're going to put your two brackets. You ask yourself, what do you multiply by itself to get 25x squared? You multiply 5x by 5x. It has to be the same thing in the first here and here. 5x times 5x, 25x squared. What do you multiply by itself to get 81? 9 times 9. Now we just have to figure out the signs. It's really easy with binomials. Just do opposite signs. You can either do plus minus, or you can do minus plus. It makes no difference. Finished. Okay, 20 y squared z minus 5z. Okay, at first glance, looks like this is not something that we can factor, because 5z is certainly not a perfect square. We do have the minus sign, which is good, but it doesn't look like it's a perfect square. But remember Yonell's rule. We must always look to see if there's a greatest common factor we can take out. In this case, there is. What can you, what's the greatest common factor of these two things, of these two terms? Look at the numbers first of all, 20 and 5. What can you divide them both by? 5. Y squared, but there's no y's there. You can't take a y out. Z, hey, we can take a z out of each one too. Now we ask, what's left? What do we have to multiply 5z by to get this first term? Well, we have to multiply by 4. We still need 2 y's, but we don't need any z. We already have the z out front. Minus, what do we multiply 5z by to get 5z? Well, better multiply it by 1. And you do need to put that 1 down. Okay, now don't stop. Look inside the brackets here. Do you see that this is a difference of squares? This is a binomial you can factor. You have two terms, there's a minus sign, and these are both perfect squares. So we're going to put our two brackets down again. We're going to remember that this greatest common factor we took out has to drop down, still has to be out front. What do we multiply by itself to get 4y squared? We multiply 2y times 2y. What do we multiply by itself to get 1? 1, 1. The signs, make 1 plus, 1 minus. I usually put plus first, but it really doesn't make any difference whatsoever. If you want to put the minus first, that's totally okay. Okay, that's the second type, binomials. We have two more types to go. Okay, the third type is simple, or simpler. Maybe I should put simpler. Simpler trinomials. They're not simple, but they're a little bit easier than the more difficult trinomials that we'll do last. Simpler trinomials. So this is a question. Questions like x squared plus 9x plus 14. Okay, remember these are the little puzzle ones. You have to ask yourself, what are two numbers that multiply to this last term and add to this? Although the way, if you're not very good with your negatives, you can think of it like add or subtract. But if you want to be very, very strict about it, it should be add. But we'll think of it as add, subtract. Okay, so what we do is we put two brackets down. What must be in these first spots to end up with x squared? Because the way you get this first term is you multiply this times this. What must it be to get x squared? Well, it must be x times x. Now I'm looking for two numbers that multiply to 14 and add to 9. Let's pretend you don't know what they are. Okay, well here's what you can do. You can make a little list. Well, I know 1 times 14 equals 14, and I know 2 times 7 equals 14. 3 times, no, 4 times, no, 5, no. Oh, this is it. This is the only numbers here. Which of those pairs add or subtract to give 9? Well, it's the second ones. It's not these ones. It's this one. Okay, more trick if you want it. More tricks if you want them. You can drop this sign down, so it's plus, as long as you put the bigger number there first. So the bigger number is 7. The other number is 2. Now, to figure out this sign right here, you have to do some thinking. You have to ask yourself, Would it be positive 7 times positive 2 to give the positive 14 up here? Or would it be positive 7 times negative 2 to get the positive 14? Well, I hope you agree with me. It would have to be positive 7 times positive 2. There you go. There's your answer. X plus 7, x plus 2. If you want to check it, multiply this binomial by this binomial. In other words, do mountains and valleys. And I assure you, if you do mountains and valleys and collect the terms, you will get exactly what we have as our question. Okay, let's do another one. We'll do 3 of these ones. These are probably the ones you need to know the most. Like these, hopefully you can get to the point where these ones don't make you cringe. You can get these without too much trouble. X squared minus 4x minus 12 looks like a good trinomial to factor because you got a x squared and then an x and then just a constant. So we'll put our brackets. You should know what goes at the start, x and x. If you want, you could even put the sign, drop the sign down, minus, as long as you put the bigger number here. Okay, what are we looking for? Two numbers that multiply to 12. Well, it could be 1 times 12. It could be 2 times 6. It could be 3 times 4. It could be 4 times 3, but we already have 4 times 3. Once you find a pair that repeats, you found all the pairs. So there's only 3 pairs here. And we want two numbers that add or subtract to 4. No, yes, right here. These ones add or subtract to 4. They subtract to 4. So you put the big number first, smaller number second. Is it negative 6 times positive 2 equals negative 12, or negative 6 times negative 2 is positive 12? Or negative 12, sorry. It's negative 6 times positive 2 to get negative 12 here. That's it. We're finished that one. One more of these. Negative 3x squared plus 9x minus 6. Now, this looks more difficult because we got a negative up front, we've got numbers in front of the x squared. But remember, what's the first step that I've neglected to mention these last two questions? You now must have been very angry with me. The first thing you want to do is you want to see if you can remove a greatest common factor. And there's definitely a greatest common factor here. I hope you agree with me. The greatest common factor is 3. So you want to take out a 3. But you want to do more than that. If we just take out 3, we'll be left with negative x squared. And we don't like having negative in front of the x squared. We want that x squared to be positive. So why don't we take out the whole negative 3? What's that leave us with? That leaves us with x squared. Now, what do you multiply negative 3 by to get positive 9x? Multiply it by negative 3x. What do you multiply negative 3 by to get negative 6? You multiply it by positive 2. Okay. Now, there's our greatest common factor, which is great. We're going to write that down again. But what we have left in here is a trinomial that we can factor. Okay, x squared, so that's going to become x and x. We're looking for two numbers that multiply to 2 and add or subtract to 3. Well, 2, the only numbers that multiply to 2 are 1 and 2. So we must have 2 as our first number, the big number, and 1 is our second number, the smaller number. Drop this sign down. Negative 2 times what equals positive 2? Negative or positive? Negative times a negative. Okay, that's the answer for that one. Okay, the fourth and final type of factoring that you need to be familiar with, for now, we'll do some other factoring later on in this course, but for now, is tough trinomial, or tougher trinomial. Why don't I call it that? Tougher trinomial. And this is the Bobby bridge method. Okay, dear Bobby, who left us in grade 11, we'll remember her fondly forever for helping us come up with this method, or at least naming this method. Thank you, Bobby, wherever you are. I'll never forget you. Okay, we're going to do 2 of these. So the first one is 3m squared minus m minus 2. Okay, now do you see this is different from the simpler trinomial? First thing we try to do is we try to factor out a greatest common factor, and we'd love to factor out this 3, but we can't, because you can't divide m by 3, and you can't divide 2 evenly by 3, so you can't remove this greatest common factor. You're stuck with a number in front of the m squared, and if you have a number stuck in front of the m squared or the x squared or whatever letter here, that's when it's a tougher trinomial. You need to use Bobby's bridge method. So the reason it's called Bobby Bridge is because Bobby builds a bridge here from the 3 to the 2, and when she multiplies those together, she gets 6. Or if you're good with your positives and negatives, you can think of -6. So now what we're looking for is two numbers that multiply to 6. So what could that be? Could it be 1 and 6, 2 and 3, 3 and 2? Oh wait, that's the same thing. So we've already gotten them all. There's only 2 sets. And they have to add or subtract to the middle number. What number is here? It's a 1, right? If you don't see it, there's a 1. So which of these numbers add or subtract to 1? There they are right there. Okay, the real name for tougher trinomials is decomposition. Because what you're going to do is you're going to break this middle term down. You're going to decompose it into these two terms. So we have 3m squared minus, we want to end up with -1m. So why don't we put -3m plus 2m minus 2. You see what we did here? This amount right here, what's -3m plus 2m? -1m, and that's exactly what we had here, right? We decomposed this -m into this here, but this is actually completely equal to that. We haven't made a new question or anything like that. I mean, it looks different, but it's the same amount. Okay, now what we do is we pair them up. So we're going to pair up the first two and the second two. And in each case, you ask yourself, what's the greatest common factor here? Well, the greatest common factor of 3m squared and 3m is 3m. What do you multiply 3m by to get 3m squared? M. What do you multiply 3m by to get 3m? 1. Plus. Put that sign. Whatever side. If that was a minus, you'd put minus. But it's a plus, you put plus. Same thing over here. What's the greatest common factor? 2. 2 times m equals 2m, and 2 times 1 equals 2. If you've done it right, you should get the same thing in both brackets, and we did. So you take that part in brackets out. It's kind of like a greatest common factor. You take that out, and what's left is this, 3m, and this, plus 2. We did it. That is a tougher trinomial, Bobby Bridge method. Okay, one last question, and that's it. If you need more help, please, please, please come see me. You need to learn this stuff. Okay, let's do this one in blue because it's pretty. 10m squared minus 9m minus 9. Okay, you now wants us to look for a greatest common factor, but there's nothing you can divide all three of these terms by. So we know we're going to be doing Bobby's bridge method because we have a number out front of the m6 squared. So build the bridge. 10 times 9 is 90. We're looking for two numbers that multiply to 90. My goodness, it could be 1 and 90. It could be 2 and 45. It could be 3 and 30. You see I'm just going up, 1, 2, 3. Does 4 go into 90? No, I don't think it does. You could use a calculator if you want, but I don't think it does. 5 times 18, 6 times 15, 7, no, 8, no, 9, yes, 9 times 10, 10 times 9, oh wait a minute, it repeated, so we know we've hit the end of our list. This is the complete list right here. So we got 6. We want two numbers that add or subtract to 9. No, 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 hey, look at those. Those subtract to 9. Those are the numbers we're going to use. So we're going to decompose this middle term, 10m squared. We have to end up with -9. We need more negatives, so start with the big one. -15m, don't forget the m, plus 6m, and now those two terms together equal the -9m. Perfect. We've decomposed it. By the way, if you put these in the opposite order, you put 6m, as long as you put plus 6m minus 15m, it's still going to work. It's kind of cool to try it both ways, but I won't do that today. Okay, pair them up. So many nice colors. What's the greatest common factor of 10m squared and 15m? Well, I can take a 5 out of both of those and also an m. 5m times what equals 10m squared? 2m minus 3 plus greatest common factor of 6m minus 9 is 3. What do I multiply 3 by to get 6m minus 9? Well, I multiply 3 times 2m and 3 times -3. Yay, it worked. I have the same thing in both. So I'll take out the 2m minus 3, and what I'm left with is 5m plus 3. Finished. Okay, I'll say it once more. I know you're sick of it, but please, if you could do everything in your power to learn how to factor, that'd be great. Last thing I'll say is there's other ways to do these, the tougher trinomials, the decomposition, the Bobby-Bridge method. Your textbook shows you other methods. I don't care which method you use. You can use any method you want, but you must be able to do it. Okay, you have to be able to do it consistently every time. I will use this Bobby-Bridge method all the time on the board because I don't want to confuse people by showing different methods. But you can use whichever method you want as long as you understand it and as long as it works. Okay? So endeth the lesson on factoring. Can you